Okay, hi everybody. We're going to use this lecture for SPSS methods for the correlation and regression. First of all, let's take a look at an overview. How do we do that in SPSS for correlation? In SPSS, the correlation and associated p-value can be obtained by doing analyze, correlate for correlation, and bivariate. So bivariate means there are two variables. And move variable names to the box on the right and click OK to do that. For illustration, we're going to revisit the example that we did in the other lecture. So in an effort to determine whether ACT score is a useful college admissions tool, the correlation between ACT score percentiles and end-of-year GPA for first-year students is examined. The following data is collected, with the ACT score as percentile in the first column and GPA as the second column. So we'd like to test if there is actually a relationship between these two variables. And we understand if we want to use the correlation test, we have to start with these two alternate hypotheses. Null will be rho equals 0, no correlation, no linear correlation between these two. Alternative will be rho is not equal to 0, indicating there is a linear correlation between these two variables. Now let's go ahead and move on to SPSS. So in SPSS, we have this data sheet with the original data values of ACT percentile, high school GPA, honors classes, and extracurricular courses, and GPA. Okay. And if we want to look at our variables, we can see that the GPA at the end of the second semester, okay, let me widen this a little bit. GPA at the end of second semester in college is GPA, and a percentile score on ACT is the ACT percentile, this one. All right, so let's do correlation between testing if there's correlation between ACT percentile and GPA. As we just mentioned in the overview, we go analyze, and then you do correlate for correlation. And we are going to go bivariate because there are two variables involved, bivariate. And let's move our variables over. So we're testing between percentile scores. Okay, you can even enlarge this to see the full label of the variable. So ACT percentile, as well as the GPA at the end of second semester, which is the end of first year. Okay. And you can just leave the Pearson coefficient as it is. Leave two-tailed test of significance as it is because we're doing rho is not equal to 0 anyway. Options is really options. You can check means and standard deviation if you want to know the means and standard deviation for both variables, but it's not required. Okay, hit OK. Okay, and then you will get this table, which is the correlation table being simply produced. And you can copy and paste this table again. Now, sometimes I feel like some of you guys don't really know how to copy it, so you can copy as image if you want to paste into your Word file. Okay, copy as image. Or simply hit copy if that works for you. So going back to this table, let's explain some of the numbers. What do they represent? Now, N represents sample size. As we mentioned, there are in total, looks like there are 12 student score being investigated. So sample size is positive 12. And then when we look at the correlation, these numbers represents correlation coefficient, like 1.067. So if you check percentile score on ACT, percentile score on ACT, of course the coefficient is going to be 1. And then GPA at the end of second semester and percentile score on ACT, this is the actual correlation coefficient between these two variables. So this is our R, okay? So this is going to be our R, right? And then next, the 0.836, this is going to be the p-value for correlation test. So if you remember what we did in lecture, we're going to say null equals to row equals 0, alternative is row is not equal to 0, p-value is 0.836 based on the table, and reject null if p-value is less than 0.05 for rejection rule. In our case, fail to reject null, there is not sufficient evidence to conclude that ACT score and GPA are linearly related. Effect size for correlation is going to be the R, okay, which is going to be this 0.067. So that indicates a lack of meaningful relationship between ACT score and GPA based on the guideline. Now, you probably have noticed that a t-score for the tested statistic is not given by using this correlation table. That's one of the drawbacks of using the SPSS. However, the p-value is given. That is sufficient for us to make decision regarding the null hypothesis. All right, next let's move on to the regression. Okay. In order to get the regression equation in SPSS, we should click on Analyze, Regression, and check Linear. Suppose you want to get linear model, which is what we covered in this chapter. Move the dependent variable, which is to be predicted, the dependent variable to the dependent box, and move the independent variable, which is what is used to do the predictor, to the other box and click on OK. Now, going back to this question, we can use ACT score percentile as in order to simply predict the GPA score, right? So let's move on to the SPSS. Okay, so in SPSS, we go Analyze, and this time we're doing regression line. So hit regression, and then we're going to use the linear model. So do linear. Okay, dependent, and independent. So dependent is what you are trying to predict, right? We're trying to predict GPA at the end of second semester. So GPA is going to be your dependent. While independent is going to be ACT percentile as independent variable. All right, and then hit OK. That's going to be the easiest one for you to do. And when you do this, you are going to get a bunch of tables being produced. So the first table tells you which one is dependent variable, which one is independent variable. So dependent variable is GPA at the end of second semester, which makes sense. Okay, so what's useful for us is going to be this model summary, okay, which gives you the correlation coefficient R, and R squared, that's for the coefficient of determination, right? So model summary is what you need, as well as the coefficients for regression line, equation of regression line. So these two are most important tables for us. Make sure you copy and paste these two tables into the Word file for your homework assignments. So let's see how do we make use of these two tables. Okay. So as we mentioned, R is correlation coefficient, and R squared is coefficient of determination, which is used for effect size of the regression. And then coefficient, these two coefficients will help us to get the regression equation. Now, it says very clear. This constant is 3.05. So GPA, which is the dependent variable, GPA equals to 3.05 as the constant, and then plus the coefficient 0.004 in front of the percentile score on ACT. So GPA equals 3.050 plus 0.004 ACT. Okay. Again, these two are very easy to see, but you do not want to mess up the order of these two. It says very clear 3.050 is constant, so it's by itself. Okay. Now, sometimes we may want to include more than one independent variable in the regression equation. In that case, it's called multiple regression. So multiple regression means you include more than one independent variables in order to predict another dependent variable. So in our GPA examples, we can add more variables such as high school GPA, number of AP honors IB courses the student has taken, and number of extracurriculum activities in high school into the equation in order to predict the student's GPA in the end of first year in college. Okay. So what you do is in SPSS, just move those variables to the box on the right with the other independent variables. Let me illustrate this real quick. So what you do here, we can just go analyze regression and still doing a linear model, right? But the difference is we're using not only one independent variable, we're also using high school GPA, as well as number of AP courses the student has taken, as well as number of sports or the clubs in high school, extracurriculum activities, into the independent variable. All of these variables might take effect in trying to predict what's going to be GPA at the end of the second semester in college, and hit OK. Then you would see this table coming up, the new table, which gives you a bunch of more coefficient. Let me show you. Let me here move it over. So what you need is this model summary as well as the coefficient. What's more important is this coefficient table, okay, which gives you constant and a coefficient in front of each independent variables. Okay, so after you have copied and pasted these tables, let's see how do we make use of these outputs. So as we just mentioned, these boxed item represents the coefficient of these independent variables. So if we make use of these coefficients, we can get the equation with all the variables would be dependent variables GPA, college GPA, equals to constant 2.5 and a coefficient negative 0.022 in front of the ACT, and then plus 0.924 in front of the high school GPA, and minus 0.009 in front of the number of AP honors courses, and minus 0.135 times the number of the simple clubs. With the additional variables, the coefficient of variation turns out to be 0.688 coefficient of variation, which is going to be this number, r squared, okay, which means 68.8% of variability in college GPA this time can be accounted for by the combination of these variables. Okay, so that's what we do in so-called multiple regression. Multiple regression idea is pretty similar to the simple regression. The only thing changes is you have included more than one independent variables. Okay. All right, so that's the end of this SPSS session. Let me know if you have any questions. Thanks.